All right, so section 10.5, reference angles. Let's go over some basics before we actually go into some of these problems. So the basics are, first off, let's talk about conversion. Okay, so I'm going to want you guys to convert everything to degrees. If it's already in degrees, then great. But if it's not, I'm going to tell you to convert it because a lot of times it's a lot easier to do. Okay, so a radian to a degree. That's what we're going to do. So a radian, bless you, to a degree. So you're going to get your radian measure. You're going to multiply it times 180 degrees over pi. And that's going to give you your degree value. This is the only little formula you need. Okay? So that you can figure out what is the degree that they're giving you. Okay? If you know the degree, it's usually easier to figure out references. Now, aside from that, it's important that you remember a couple of different angles. Okay? It's not too many of them, but a couple of different ones. Let me kind of draw a really quick XY graph here. I'm going to draw two of them. So I just want to list two angles to make sure that you guys understand what you're looking at. But if you start from your standard position, which is 0 degrees, okay, I'm going to put 0 degrees right there just so you know. And I rotate halfway. That's 180 degrees. Okay? That's 180 degrees. But if I rotate backwards, that's negative 180 degrees. It's still 180. Let me move this up. It's still 180, but it's in the negative direction. Okay, so if we spin, and it's kind of hard now to say clockwise because a lot of people don't see clocks that much anymore, right? But if you spin in a clockwise direction, the way a normal clock would spin, it's considered a negative angle. If you go backwards, like trying to turn back the hands of time, right? Then that's considered a positive angle. Okay? So if you see negative angles, positive angles, this is the same thing. That just means that they're spinning it the other way around. Okay? And then, if they spin it all the way around, that's 360 degrees. But remember, they can also spin it the other way around, right? The whole way. They can go this way. And that's negative 360 degrees. So it just depends on which way they're spinning it, okay? Counterclockwise is positive, so I'll write that down for us right here. Counterclockwise is positive. Clockwise is negative. So the way the clock moves, that's considered negative angles. Okay? If you try spinning it backwards, that's considered a positive angle. And that's pretty much all you need to know in order to do this stuff. Okay? Now, to find a reference angle, it just depends on where the angle is. Has it passed the halfway mark? If it has, if it's past the 180, then you got to try to figure out, okay, how do I draw them? So here's your guide as to how to find your reference angle. So how to find a reference angle. All right. So I always tell people this is kind of like the black widow symbol. I don't know if you guys know what I'm talking about, but let me show you. So if this is the angle they give you, okay, then you always reference the x-axis right there. You always reference the x-axis. So I'm going to put that in real quick right here. Always reference the x-axis. In other words, this is the angle you're looking for, okay? You draw a line straight down to the x-axis, and you're going to reference it. That means you're going to reference the x-axis, and you're going to look for that little angle that it creates. Okay? If your angle is way over here, still do the same thing. Reference the x-axis. Okay? And this is the angle they'll be talking about. Okay? So if they happen to draw an angle that's like way out there, then draw a line from the line that they're giving you as your angle, and then you're going to reference that little triangle angle that you made. So like if I have an angle that's down here, then I'm going to draw this little imaginary line right here, and this is the angle that they want me to find. Not the huge angle that it's going to take. In other words, this is what I'm talking about by the huge angle, like this big green one. Not that. That's not my reference angle. It's the tiny little theta on that bottom triangle. Just that little piece right there. Okay? Not all of it. And you can also get the same idea over here. This is what I meant by kind of like a black widow symbol, right? Anytime you try to find a reference angle, you always want to try to reference the x-axis and figure out that angle in there. Okay, like I said, I know this sounds kind of weird. I'm hoping that once you see me do some problems, you're like, okay, that's not that bad. It just looks worse than it is, but it's not that bad. So we'll check right now. So remember, referencing the x-axis, we may have to convert some angles. And don't forget 180 degrees, 360 degrees. Okay, those are the two main ones that we got to do. So let's look at some problems really quick. Let's look at number 4. I mean, since it's right here. So they want me to find the reference angle to 135 degrees. And you can draw that really quick. It doesn't have to be perfect. Just make sure you guys label this part right here, okay? Label that so that you know, like, oh, 135. That's the angle they're talking about. But that's not my answer. That's not what they want. They want this little piece right here. They want to know, what is that angle? Okay? Now, if I get 135 degrees plus theta, how much is this supposed to equal? If I add this much more? 180. Good. So all I have to do is subtract 135 degrees on both sides. Theta is 45 degrees. And that's how much is missing, right? How much is missing from 135 to get to a straight line? That would be 180 degrees. How much more would I need? I need 45 more degrees. Does that make sense? You're just trying to complete the angle. You're either going to try to go, you're trying to make it flat. You're trying to get it to a flat point. Whether you go down that way or backwards up, we'll see right now. But that's kind of what you're looking at, okay? Just try to figure out how much more would I need to get that flat line. Or if you happen to go too far and you pass the flat line, you might ask yourself, how much would I subtract or need to go back, right? How much is it? So let me try to show you a different one, maybe another degree one. So here's number 3. Here's another degree one. Well, you know what? I don't know if I want to do that because that's still in quadrant 2. Let me see if I can find one that's not in quadrant 2. That's in quadrant 1. There's a lot in quadrant 2. All right, here's one. Number 7. So 220 degrees. Then right now we'll do 2 radian ones. That way you can practice the radian conversions, and then we'll be done. So 220 degrees. Now, remember, you're supposed to reference up here, okay? This angle is what I want. Let me not use blue there since they're using a blue. Let me use green. So my actual angle is 220 degrees. But I'm trying to figure out from 180, how much more did I go? From 180 to 220, how much more did I go? Right? So I was at 180 degrees. I added a certain angle, and now I'm at 220. Okay? So from 180, we added that green little angle, and now we're at 220. Remember, you're using 180 and 360 as references sometimes, right? So if I subtract 180 on both sides, what's my answer come out to? Anybody know? 40, right? You should have those phones in the pockets, guys. So that should be 40. So here we go. That's it. All right, so you're just asking yourself, oh, I went over. Over by how much? We're supposed to be at 180, but I'm at 220. How much did I go over by? 40 degrees. Right? Let me show you number 8. This will just be an extra one. Because it's a negative angle. I want you guys to see one with the negative angle. Just because the angle is negative, notice how our answers are all positive. It doesn't mean that your answer has to be negative too. But notice negative 340 degrees. It almost got to 360, right? How much short was it? How much does it need? Right? Let me put this. Yeah, it needs 20 degrees more, right? All it needs is 20 degrees more, and it'll finally get to 360. That's how short it was. Just 20 degrees. That's it. Okay? So it got all the way around 340 degrees, and it was short by 20. So that's your reference. Okay? Remember, your reference is always what's in between the blue arrows, right? They have 2 blue arrows. So that's why I put the little green angle in between there. If you look at number 7, right? I'm referencing this part, quadrant 3 over here. Okay? I'm using this to reference. So I'm just looking at that little piece right there. And by the way, if you wanted to do this in terms of showing work, you just say 340. I know it's a negative angle, but just think of it as a positive. 340 would give me 360. So if you subtract 340, you get 20. Okay? Again, you're just trying to say, like, either I'm going to try to get to 180, or I'm going to try to get to 360, or maybe I passed 180. How much did I pass it by? Right? That's all you're looking at. So let's go to number 1. I think number 1. Yeah, so look at number 1. So my reference angle is here. And right now, I'll wait for you guys to draw this. But here's my reference angle right there. All I need to know is what is 5 pi over 3. And we already talked about this, but I want to show this to you guys. And then once I know what 5 pi over 3 is, then I can say, okay, if it's this many degrees, how much more would I need to get a full revolution? Because that's kind of what it's trying to do, right? So remember, we're going to do a conversion. 5 pi over 3 times 180 degrees over pi. Okay? So I'm trying to figure out the answer for this. This is 300 degrees. So I'm going to mark this right here. I'm going to put 300 degrees. Okay? 300 degrees. How much is missing to get it to 360? If I'm at 300? 60, right? this has to be 60 degrees. But if you look at your ABCD, there's no 60 because I got to convert it back. So to go back to a radian, I'm going to get my 60 degrees and multiply by pi over 180. That comes out to pi over 3. So that would be D. So it's the same thing as the other problems, just that you may have to change around some of the angles. Okay? You're going to have to change them to like a normal degree. That way you can mentally do it and then change it back. So right now I'll find another one of these radian problems for us. Okay? So let's see. That's degrees. So here's a radian problem. I don't know if I can do, yeah, I might be able to do this one. All right. So 13 pi over 18, I don't know that angle. I know angles that end in pi over 3, pi over 4, pi over 6, pi over 2. I can do those, but pi over 18 is a little different. So I'm going to do a conversion really quick. 13 pi over 18. I'm going to change it to a degree. So 180 degrees divided by pi. I know the pi's will cancel. And 180 divided by 18, that's 10. So 10 times 13 is 130. This is 130 degrees. Okay, this is 130. I need to know, how much is this? It would be 50. What number did you reference it with? 180, right? You said, okay, we're trying to get a flat line. A flat line is 180 degrees. If I'm at 130, I'm just going to kind of do the work really quick. Plus this angle, it should be 180. Notice you guys don't have to show the work. You can do this in your head. I'm just showing it to you guys, though, just for the purpose of having it there. Theta would be 50 degrees. Now, again, you don't see any 50 there. Okay? That means you're going to have to convert it back. Okay? So 50 degrees times pi over 180. I can reduce that by 10. Bless you. Notice they both end with a 0, right? 50 and 180 both end with a 0, so I can knock that off. That gives me 5 pi over 18, which is right there. Okay? This is reference angles. Okay? You're going to be checking them with either 180, 360. If it falls short of 180, ask yourself how short. If it barely passed 180, ask yourself by how much. Those are your references. If it's almost 360 degrees, how short is it from 360? Right? That's all you got to ask yourself. How much more would I need, or how much extra did it go? Right? That's basically it. So I'm going to go ahead and stop right here. You guys have your assignment. You can work on that.